Welcome to Chemistry Lab. In this lab we will find the density of a solid for which it's easy to measure the length, width and height. Then we will find the density of a liquid, namely water, and in the end we will find the density of an object for which you cannot measure the length, height and width. So finding the volume would be a little bit tricky. So let's get into the lab and see how these three densities are measured. So we have a block of wood and we want to find the volume of this block of wood. The first thing we need to do is measure its length. So use a centimeter ruler, and the length of this piece of wood is 9.9 centimeters. So length is 9.9 centimeters. Next we want to find the width of this piece of wood. The width of this piece of wood is 3.7 centimeter. So 3.7 centimeter. And now we also want to find the thickness or the height of this piece of wood, and the height of this piece of wood is 2.0 centimeter. So please make sure that you write these length, height and width down, and then you can multiply these three together to get the volume. And do not forget to write a unit for volume, the appropriate unit. Next we want to find the mass of this block of wood. So we put this block of wood on a triple beam balance, and how the triple beam balance works is there are these three beams and we move these sliders until the beams are horizontal. So when I move the last slider to 40, the beam dips down, which means 40 is too much, so I move it back to 30, and now the beam goes up, and now I'm going to move this small slider until the beam becomes horizontal. So now you can see that the beam is actually horizontal, and on the last beam it says 30 grams, and on this front beam it says 1.7 grams. So I would add 30 and 1.7, so the mass of this block is 31.7 grams. So now you can divide the mass of this block by the volume of the block to get its density. In the second part of this lab, you want to find the density of water. So I've got some water here, and I will need a graduated cylinder. So first thing I do is I put the graduated cylinder empty on the triple beam balance, and then I try to figure out the mass of this empty graduated cylinder. So it's less than 60, it's more than 50. So I can see that when it is at 50 and 50.0, it's not balanced. So then I move this slider, and now I can see that the mass of the graduated cylinder is 52.0 grams. So please write this down somewhere in your lab report, that the mass of the empty graduated cylinder is 50 gram. Next we take the water and we pour some water into the graduated cylinder. About 50 to 60 centimeter cube or 50 to 60 ml is good. So don't fill it up all the way. So right now the volume of water in the graduated cylinder is 54 centimeter cube. Okay, so we now have the volume of water is 54 centimeter cube. Next we take the graduated cylinder and we place it on top of the triple beam balance pan, and we see that the beam has gone up. So let's move it all the way to 90, move all the way to 100, and the beam still stays up. It means that the mass of the water and the graduated cylinder is more than 100. So let me pull this back and move this big slider over to 100. And now I have three sliders working together. So when I move the slider on the back beam there, it's dipping. So the mass is somewhere between 100 and 110. So I will now adjust the smallest slider until the beams are horizontal. And it seems that the beams are horizontal here, and at this point what you can see is that the middle slider is at 100 grams and the back slider is at 0 grams, and the smallest slider is at 5.4 grams. So that means that the mass of the cylinder with the water is 105.4 grams. So please record that. Total mass is 105.4 grams. Now, how do I get the mass of the water? Is by subtraction. So go ahead and find the mass of the water. Once you have the mass of water, you can find the density by dividing the mass of water by the volume of water. Now I want to find the density of these little glass marbles, and I do not know the volume, but what I do know is that in this graduated cylinder from our previous part, we already know that the volume of water here is 54 centimeter cube or 54 ml. So please write that down. Initial volume of water is 54 ml. Also, when we did the last part of the lab, we said that the mass was 105.4 grams. So that would be the initial mass of the graduated cylinder. So what I'm going to do next is put these marbles into the graduated cylinder very carefully, and you can notice that as these marbles go in, the level of the water is rising up. So this method of finding the volume of an object is called the displacement method. So I've put all of those marbles into the graduated cylinder, and now the new volume I have is 88 ml or 88 centimeter cube. So what is the volume of those marbles? It would be 88 minus 54. So new volume minus the old volume. So I now have the new volume, and the next thing I need is to find the new mass. So to find the new mass, I'm going to put this graduated cylinder with the water and the marbles back on top of the triple beam balance pan, and then find out what is the new mass. So it's more than 140, more than 160, more than 170, less than 190, more than 180. Right. So now move the smallest slider, and it is now balanced at 180, and the smallest beam is reading it at 4.5. So the new mass I have is 184.5 gram. So subtract from this mass the mass of the graduated cylinder with just the water in it, and you'll be able to get the mass of the marbles. And after you have the mass of the marbles, divide the mass of the marbles by the volume of the marbles, and that will give you the density of the marbles. So I hope that you enjoyed doing this lab.